Lesson 3.6, Proportional and Non-Proportional Relationships. Our essential question is, how do you write an equation in function notation to represent a graph? Our vocab word for today is slope-intercept form, which is basically the same thing as function notation for a linear equation. So what you see on the definition side is f of x equals mx plus b. That's going to be the general form that we use for our function notation or equation to represent our lines today. You may notice that it looks familiar. It looks very similar to the equation that we used for arithmetic sequences, because arithmetic sequences are linear. They are linear. The graphs of arithmetic sequences are lines. So that's where the similarity comes in. It's a little bit different though, in that if you look at the definitions for m and b, m we call the slope of the line. That should make sense. It's the rate of change, how much that arithmetic sequence was increasing or decreasing, that constant that was going up or down. But b is now called the y-intercept, which is where the graph crosses the y-axis. This is not the same as the first term in the sequence. This is not the same as term number 1 in the arithmetic sequence. This is actually like term 0, because where it crosses the y-axis, the value for x has to be 0. So hopefully you will understand once we start working with these graphs and writing the equations. If not, please check in with your teacher. Okay, the first two graphs, it says find the slope of each line. So to find just the slope, not write the entire equation, I'm going to show you what you need to do. The slope, or the rate of change, we defined before as the change in y over the change in x. We also said you could use a formula, y2 minus y1 over x2 minus x1. I am going to go with the first method, the change in y over the change in x. I am going to identify 2 points on this blue line that clearly cross through the intersection points, the corners, like on that coordinate grid that's in the background. So for example, this point, oh, my calibration's a little off. This point right here, to me, goes through right where those grid lines intersect. It's at a corner. And then the next point that looks like it's at a corner to me is right here, this point. So now I'm going to count how much y has changed from one point to the other. So I'm going to go straight up, and then I'm going to see how much x changed by going straight across. So the change in y over the change in x. So counting my change in y, I went up 1, 2, 3. Counting my change in x, I went across 1. So my slope is 3 for that first line. So change in y over change in x. This slope of this line is a positive slope. It's going up from left to right. So my slope is positive 3. My second graph. This point looks good to me. And then I'm going to say this point right here looks good to me. So change in y over change in x. This graph is going, I'm going to have to go down. If I start at the point on the left, which is what I always do, I'm going to have to go down 2 and then over 3 to the right. So my change in y is a -2. My change in x is 3. I always start at the point on the left. Start at the point on the left. So that's pretty important when you're counting your slope. Start at the point on the left. It's just like reading. You read from left to right. When you read words, you should read your slope from left to right. So start at the point on the left, rise over run. That's another way of looking at the change in y. You could call it the rise. It's like standing up, and then the run, you run across. And I always have my run going to the right because I start at the point on the left. Okay, 2 more just to practice the slope. Good spots. This one looks good right on the grid lines. And this one looks good to me. So change in Y over change in X, or you could call it rise over run, or subtract your coordinates if you want to write out the coordinates for those 2 points. All of those are ways to get your slope. So this slope to me is a negative again. So I started my point on the left. So my change in Y, I had to go down 3, and then change in X over 1 to the right, so negative 3. My second slope, this one's a little bit tougher to figure out with my grid lines. This point way over here looks really good to me. And I guess this point way over here. Sometimes it's tricky. Sometimes it's tricky to figure out which points you should use. You really want the ones that go through right at those corners of the grid lines. You could always check your slope out afterwards and count it from a different spot to see if it looks right. So I have to rise 3, and then my run looks like it is 8. And that fraction does not reduce. Does not reduce 3/8. So there really aren't any other points in between those two that were better to use. Because if there were, it would reduce, and then I could check to make sure that it made sense. For example, on this upper problem, if I go down 3 over 1, and then I go down 3 over 1 again, I hit another point that's right where those grid lines cross. And then I could do that again, down 3 over 1. You get the idea. Now we're going to write the equation. So we're not only going to find the slope, but we need the entire equation here. So the slope is going to be filled in the spot where it says M, and then the y-intercept is filled in the spot where it says B. So first thing I'm going to do is find the slope. So start at the point on the left, go to the one on the right. So change in Y over the change in X. I'm going to have to go down 1 and then over 4, it looks like. Down 1, over 4. So negative 1/4 is my slope. And then my intercept is just where the line crosses the y-axis. So the y-axis is vertical. So the point where it crosses the y-axis is right here. It's negative 1. So now I just need to plug in these two values in my equation. So negative 1/4, then the x goes after that, and then my intercept is negative 1, so minus 1. So my equation is still going to have the letter x in it, the variable x, because that is our independent variable. So f of x equals negative 1/4 x minus 1. If you wanted to write your intercept with a plus, you could do plus negative 1, and it means the exact same thing. So that's up to you. I just prefer to write it as minus when it's a negative number like that. Okay, another one. This one doesn't have the dots on it for us, so we're going to have to figure out the 2 points that we want to use. I always recommend using the intercept as one of them, because you're going to have to name the intercept anyway. So here's my intercept. It's at negative 2. So I could already fill in that part of my equation right now. And now all I've got to do is find my slope. So one more point to use. This point right here looks good to me. So I'm going to rise 3, run 2. So my slope is 3 over 2. Up 3 over 2. This is a positive slope. It's going up from left to right. My last one, this one has some dots on it for us. So if I use these two dots to find my slope, I'm going to start at the point on the left, go up 4, and then over 6. What you may notice is that fraction reduces to 2/3. So I want to use 2/3 in my equation here because you always want it in lowest terms. And then it looks to me like this is the point that's my intercept. So plus 1, plus 1. Positive 1 for my intercept. Now notice with my slope, if I check it and I go up 2/3 and then up 2/3, it does work for that line. So if your slope reduces, reduce it. You're ready to write your summary now? And then for your homework, we have a couple of versatiles that we're working on, where you have to match slopes to graphs, and then where you have to match slope-intercept form or function notation to graphs. So a couple of really good versatiles.